All right, today we're going to look at solving some equations that contain these rational exponents in them. And so the steps that you want to take to do those is to make sure that you isolate that problem. So isolate the term that actually contains that rational exponent in it. You only want that on the one side of the equal sign, and you want everything else on the other side. And just remember that if you've got something like 3x to the 2/3 power, only that x in that case is brought to that 2/3 power, versus if that whole thing is in parentheses. So remember the difference between those. In this first case, you would want to make sure you divide both sides by 3 before you start working with that rational exponent. In this instance, you're going to have to take the whole 3x to that 2/3 power. Okay, so then the second step is to raise both sides to a power that's the reciprocal of the power in the problem. So for example, if we raise something to the 2/3 power and we raise it to the power that's a reciprocal of that, and reciprocal means you flip that fraction, and so it's to the 3/2 power. Well, remember, a power raised to a power, you multiply them, and so when we're multiplying fractions, it's top times top and bottom times the bottom. So that means 2 times 3 on the top is 6, and 3 times 2 on the bottom is 6. So you're making that power of 1, which is, what we want to get it back down to. So that's why we use that reciprocal. Then you're going to solve for the x, and then make sure you check for any extraneous solutions, and then write your solution. All right, so let's use an example here. So we have x to the 4/3 power is equal to 16. All right, so we want to take that x, it's already isolated to that 4/3 power, equal to 16. And remember, what we're doing is now bringing this side to the power that's the reciprocal of that exponent. So 4/3 power would then be brought to the 3/4 power. And remember, if we do that to one side of an equation, we have to do it to the other side of the equation. Okay, so this makes x to the 4 times 3 is 12, and 3 times 4 is 12. So that means that x is just brought to one power. So that is just an x. So then we have 16 brought to that 3/4 power. Well, remember, again, that's power over the root. So let's write that, power over the root. So this is brought to the 3rd power, but it's the 4th root of 16. Well, if you remember on the ones, couple of notes back, probably, we made our little charts, and I suggested you making a little flashcard of all those different powers. And so the 4th power, the 4th root of 16 is a perfect one. So we're going to make sure that we do that first. So the 4th root of 16 is 2, and then we bring 2 to that 3rd power. So it's like we did this part first to get a 2, and now we're raising it to the 3rd power. So 2 to the 3rd power is 8. And so then you could check your answer and say 8 to the 4/3 power is equal to 16. You could put that in your calculator if you want to, but that is not an extraneous solution, so x is equal to 8. All right, so here's another example. 4x to the 3/4 power is 108. Okay, so we told you before, just like in the example that I said at the beginning of this video, that 4 in this instance is not brought to that power. Only that x is brought to a 3/4 power because it's not in the parentheses. So we're going to divide both sides by 4 first, and that gives us x to the 3/4 power is equal to 108 divided by 4 is 27. Okay, so now do you remember, we're going to take it to the power that's the reciprocal of the power that it's brought to. So this is brought to the 3/4 power. So we're going to bring it both sides to the 4/3 power. And again, remember, that's power over the root. So if I see that that number has a perfect root, I'm going to deal with that first. So that's the cube root of 27 brought to that fourth power. All right, well, the cube root of 27 is 3. So 3 then brought to the fourth power is 81. So x is equal to 81. Okay, so now we have one that says, that's in the parentheses. So 3x to the 1/2 power plus 6 is equal to 0. So this whole thing is brought to the power, so we're going to isolate this term. So we're going to subtract 6 from both sides. So we have 3x is brought to the 1/2 power. It's equal to -6. Well, if you remember, anything that's brought to the 1/2 power is like the square root. Well, if we have the square root of 3x, that could never equal a negative number. So again, remember, if those are an even root, it can't be negative. If it's an odd root, it could be negative. So in this instance, we have no solution. That would be an extraneous one because that could not, we could not do this. So remember, this cannot equal a negative, okay? All right, so let's have a couple more examples here real quick. All right, so in this instance, we have, let's see, first we're going to subtract 1. So we've got -3 times 2x minus 1 is equal to -23 minus 1 makes -24. Now remember, oops, only this part is brought to that power, what's in parentheses. So we're going to have to divide this side by -3. We're still working on isolating that radical. 2x minus 1 to the 3/2 power is equal to -24 divided by -3 gives us a +8. Okay, so now we're ready to take this 2x minus 1 to the 3/2 power equals 8. And we're going, now that that's isolated, we're going to take this to the power of its reciprocal, so 2/3 power, which means we have to take 8 to the 2/3 power. If we do it to one side, we have to do it to the other. Okay, so this leaves us with just 2x minus 1 on this side, and that is 8 to the 2/3 power. So that's the 8 squared cube root. Remember our power over root? So the cube root of 8 is 2. So we can say 2x minus 1 is 2, and we still have to square it. So we've got, and I'm going to bring it all over here. So 2x minus 1 is equal to 2 squared, which is 4. So just look at this. We did this part first. Cube root of 8 is 2, but then we still had to take care of this square, even though I wrote it bad. All right, so now we just have a problem we're just going to solve. So add 1 to both sides. We still have to take care of all that. So 2x is equal to 5. We'll divide both sides by 2. So x is equal to 5/2. All right, and so our last example, again, we're going to isolate the term that has the radical rational exponent in it. So subtract 11 from both sides, and so that gives us x to the 2/3 power is equal to 27 minus 11, which is 16. All right, so now we're going to take it to the power of the reciprocal, which is 3/2 power, taking this one to the 3/2 power. Okay, so that leaves us with x is equal to the square root of 16, and then that's still cubed. Okay, so hopefully you're getting that power over root thing, and we're starting to see we're going to manipulate those to do whichever way makes sense first. And in that case, it does make sense to take the square root of 16 because we know that that is 4. And then we're going to cube 4. So remember, 4 times 4 times 4 is 64. So x is equal to 64. So there's our solution.